is radionuclide generator. We are taking example of radionuclide generator is TC99M. First we will see what is actually radionuclide generator. See, this is one system which is having the parent, and that parent can easily separate out the daughter from it, and that daughter can be easily used in clinical purpose. Okay, so this is the system holding the parent in such a way that the daughter can be easily separated. Okay, now what is technetium TC99M? See, TC represents the technetium 99. M is because of it is metastable isotope. Okay, then what is technetium 99? How we get the technetium 99? So by decaying of molybdenum 99 we can easily get the technetium 99. So this generator is the device which is used to extract the metastable isotope, that is technetium 99M, from the molybdenum 99 by decaying. Understood? See, this is the molybdenum. The half-life of molybdenum is 66 hours. So after 66 hours, the molybdenum gets converted to TC99M. There is decaying of molybdenum into the TC99M. Half-life of TC99M is 6 hours. So after 6 hours, we get TC99 from TC99M. We are interested in this isotope. So how we get? We get this isotope from the decaying of the molybdenum 99. Okay. See, the chemistry of this molybdenum, this technetium is different, totally different. Okay, because this is the decaying product of this one. Okay, then the technetium which is produced, it is produces in daily in hospital radiopharmacy, then the commercial molybdenum TC generator uses the column chromatography. So what actually occurs in column chromatography? There is acid alumina. Okay, in this the molybdenum 99 is in the form of molybdate, which contains 2 negative charge, and technetium isotope is in the form of that per-technate, and it having one single charge, one negative charge. Okay, so because of, and both are present on the acid alumina sheet. Okay, it having negative charge, so it can tightly bound to this acid alumina. It is having 2 charge, so it easily absorbed through the alumina, and because of this we get the production generation of technetium 99M. Okay, next point is quality control of radiopharmaceuticals. See, it is very strictly the quality control of radiopharmaceuticals is performed very strictly because it is the important for the production of radiopharmaceuticals. So it will include the physicochemical test. So physical characteristics and chemical characteristics. First we will see the physical characteristics. So because of quality control, we can examine the purity, then product identity, then efficacy, okay, etc. So physical characteristics, first color and state. So we should know the color and state, and we should qualify the color and state of the radiopharmaceutical product. Okay, then second, true solution. If the product is true solution, then it compulsorily does not contain any solute particle in that particular solution. Then next is colloidal preparation. In colloidal preparation there is presence of colloidal particles, so we should know the range of that particle size of that colloid. Okay, then next is pH and ionic strength. pH, the optimum pH is 7.4, but it can be vary from 2 to 9 because our blood has the buffer capacity. Okay, it can be measured by pH meter. Ionic strength, if the ionic strength is not standard of that particular radiopharmaceutical product, then what we can do, We can add acid, alkali or electrolyte. Okay. Next is apyrogenicity test. The product which we have to administer in human body, so it should not contain any pyrogen. And if it is contain pyrogen and we are administrating it, then what will happen? The person undergoes fever, chills, leukopenia, pain in joints, flushing, sweating, headache, then dilation of pupil. Flushing, it means frequency of urination get increases. Okay, this is about the apyrogenicity test. Okay, and the size of pyrogen, if there is presence, then the size of pyrogen should be 0.01 to 1 mm. Okay, and that pyrogens are either polysaccharides, proteins that pyrogen will produce by the metabolism of the microorganisms which are present in the product. Okay. Next is pyrogenicity test. In that, first is rabbit test, then LAL test. So LAL is the limulus amoebocyte lysate test. So in this, how we can determine is there presence of pyrogen or not? We have to take our sample with the LAL at 37 degrees Celsius. If there is formation of opaque gel after 15 to 20 minutes, then there is confirmation of presence of pyrogen in our product. Next is chemical test. So chemical test will include radionuclide purity and radiochemical purity. The definition of radionuclide purity and radiochemical purity we already seen in previous session. Okay. So what is radionuclide purity? It is the percentage of the total radioactivity due to the specified radionuclide which is present in the radiopharmaceutical product. So that impurities may be arrived from fission of heavy metals. Okay, then presence of undesirable radionuclide into the desirable radionuclide product. Okay, that impurities can be removed by some chemical method. It will include determination of T half. If there is impurities, then the T half get disturbed, get changed. Example, I-25 isotope of iodine contains isotope of 126. So if it is up to 1%, then it's fine, but if it is greater than 1, then it will affect to the T half of I-25. Next is radiochemical purity. So what is the definition of radiochemical purity? So this is the percentage of the total radioactivity in the specified chemical form in the radiopharmaceutical. So that impurities may be arrived by decomposition, change in temperature, change in pH, light due to oxidizing agent. So stability also get disturbed. So due to time, pH, temperature. So how we can maintain the stability? By adding the sodium ascorbate, then ascorbic acid, or placing the radiopharmaceutical product into the dark room condition. Then there are some analytical methods which are used to obtain the purity, radiochemical as well as radionuclide. Precipitation, thin layer chromatography, paper chromatography, gel chromatography, or HPLC, that is high performance liquid chromatography. Okay, thank you.